So welcome back, everyone. I hope you had a nice break and had the time to clean up a bit your mind before the debate that we'll have now. My name is David Boll. I'm a professor at UC Louvain, and I will be chairing this debate with our panelists with a lot of pleasure. So in the afternoon here, we now have 4 panelists with us that are the speakers from this morning. Unfortunately, Stefan Lang could not join us in the afternoon. He just informed us a few minutes ago that he had an internet breakdown in his region, so which means that we should limit the ecological impact of ICT, but probably make it a bit more robust as well. And we'll have to manage the debate with 4 of our speakers. So fortunately, they are great experts in this field, and so I guess that we'll have a nice time discussing these issues. So thanks everyone for filling in the posters with your questions. I'll try to make a summary of these questions and to generate and make the debate live based on them, and we see where it takes us. So we have Jens and Reyna online. Do you hear me well? Yes, you can see the other panel speakers that are there. Jacques and Gauthier, you can take off your mask if you feel okay with it.
Yes.
Okay, and of course, online you can also not wear your mask. This is perfectly fine and much more a pleasure. So I will start with the first question, which I selected as probably a good question to start the debate. We've learned that gathering data about the ecological impact of ICT at the global scale is difficult. It takes time, it's long, but we have to make decisions out of it. And these data are sometimes uncertain or with a high amount of uncertainty. So the questions that our participants to the debate here ask is, how can we make reliable decisions based on these uncertain data? And then for this, I could probably start by raising the question to our speakers that are here in presence. Gauthier, would you have an opinion on that? How can we make reliable decisions or decisions with a reliable impact based on uncertain data?
Well, I will repeat what I've said before. It's looking at the uncertainty, or at least the fact that we cannot have access to all the data because of NDAs, or that the gathering primary data is very hard and can only be done by few people. For me, and even if you have global estimates, like let's say, like you said, like ICT is 1, 2, 3, 4% of GHG emission or energy consumption, it doesn't tell you what to do. It tells nothing, but you have to act on specific territories in cities and other kind of scopes. And for me, I see more value going on a territorial scale to define in a very specific context what are the consequences of ICT and entertainment in media, to look at how we act. Like for example, I was telling it before, we can say that data centers are only 1% of electricity consumption in the world. Like from a global view, it's fine then. It's just 1% for all the value it's bringing. Yet, if you look at this consumption, it's very concentrated in specific part of the globe. In Europe, for example, it's in Dublin, Amsterdam, Frankfurt. And right now in Dublin, the national provider of electricity is estimating that data centers represent 11% of the national consumption. So it's not, so it means that there's issue regarding that, because they need to plan differently for the energy plan, for the way they will integrate renewable, because it will actually be gobbled up by data center operators. And it means that you can set up specific policies to control the development of the ICT sectors specific to territorial context.
Right, so it's a kind of a divide and conquer approach. Like we look locally, act locally, and then progress in this.
Yeah, and keeping like the global estimate in mind to know also how it is evolving on the macro level.
Mm-hmm. Okay. In link with this question, maybe it's a question for Jacques. Rebound effects. it's of course hard to capture them properly, but high the chances to capture them high when we look at local territory.
So is it easier to capture a rebound effect at local scale?
Or do we capture them?
Do we so at least what I saw from the literature is that if you look at small scale effects and short-term effects, and you do this in a very controlled environment, like you do a study and you control every parameters, it's of course easier to establish good quality quantification of rebound effects. But is it useful? So is it useful to know that, I mean, consumer, for example, if they continue to behave as they used to do, then tomorrow, if prices drop this way, like 2%, they will react in 6 months, 2 years, like that. So could be useful, but I think we are facing massive transformations. We need huge transformations of the society, and all these marginal effects, all these small step effects, I'm not sure they are useful for the global trajectory.
Okay, fair enough.
But yeah. So I think, so coming back to the previous question, I think we need to be used to rely on non-reliable data and still make decisions. And we will lose kind of reliability of the decisions, but I think we are forced to do that. And we saw it with COVID. So with like drugs, what kind of drugs can cure like COVID? So at this time, science was just building, and but the debate in the society was also very active, and it was a big problem because people did not understand why scientists could not answer to questions, and why it takes time to build science properly, and so on. And I think we are not prepared to that, but we should be prepared.
Well, COVID-19 is preparing us for this.
I hope so.
Coming back to this data, so let's assume that the data are always uncertain, or they have a certain amount of uncertainty. And then it's a question for our online speakers, for Jens and Reyna. How can we ensure that the data, even a bit uncertain, still remain in open access and up to date with respect to the evolution of technology? Because we've learned that technology is evolving very fast, and so we need to keep up-to-date data to avoid making bad assumptions. How can we make sure this remains up-to-date and open access for case studies and for testing different IDs?
I can comment that.
Yeah,
Jens.
thank you.
Also the first question, I think I urge all companies, of course, to report better, and this is something that has been developed and improved over the years. And at the moment, I think a lot of companies are doing good in that area. Network operators, data center operators. Sure, there are, I think, the big China tech companies have just started to report, but I hope they will also do better in that area. But when it comes to life cycle assessment and trying to come up with a more certain value for your product, I think that will always be a problem because there's so many suppliers, and in the end you have different suppliers and you have different sites all over the world, and you ship products back and forth between different markets, so it's very difficult to keep track of this. I usually say that if we want the system like the economic system, but for environmental data, we need at least as many employees in the world working with that. And there are about 50 million working with economic data on a daily basis. Hopefully in the future, we can make use of the Internet of Things sensors, just make sure that they don't consume, that they consume very little electricity, of course, and hopefully improve data by that. But at the moment, typically you measure the electricity consumption on a high level, and it's very hard to allocate and divide on all the different products you may produce on one site, and then the climate differs and everything. So it's always uncertainty, of course.
And is there a way, question for Reyna, is there a way that the ITU, or maybe it's already the case, adds or embeds in its recommendation to have open access data for the energy and climate impacts of ICT?
It's a hard question because we encourage there is a sort of sharing data. We have plans for instance to have like a database for GHG emission in ITU. We were thinking on doing that, but it's not very easy that every company or every sector would like to share the data. It's this part that it is encouraged, but it's not that easy. Just to put you an example of a work that we are doing, maybe it's not related to energy efficiency, but it's related to e-waste. I don't know if you know, the United Nations University is working with several countries on the e-waste monitor to develop the inventory on e-waste, you have to work in a daily basis with them in the field, and it's a work that is of years of collaboration, and I think a way to ensure it is through collaboration with the stakeholders, with the other United Nations, with other SDO, to try to find a solution for that.
Okay, so no real implementation of that at this stage, but collaboration is a way that we can agree on this in the future. So actually your answer is quite well linked to the next question that the audience has formulated, which is about the indicator. So we know there are many indicators. Today we've looked at the energy consumption, we've looked at the CO2 emissions or greenhouse gases emissions. There is an amount of electronic waste, of course. There are other indicators like the GDP, which is also important for economic viability of the innovation, but also other more alternatives like the Human Development Index or the Happiness Index. When we discuss the ecological impact or socio-ecological impact of ICT, the question that the audience would like to ask you is, what is the one indicator that you would select if you would have only one to favor? And it's a question for each of you. So we'll start ladies first, which is not a gift in this case.
It's not fair.
It's not fair.
One indicator.
If I can, maybe I can help you.
Yes, please go.
My advice is don't pick one indicator.
Really?
One is never enough. Just try to avoid the question.
Yeah, I think. Yeah, I agree with you. It's hard to find one indicator because there are many elements that are there. So, yep, I don't know what the others have to say for this.
So imagine now that the world picks the GHG emission as the one indicator. What could be the drift? What could be the drawback of that if this is the only indicator that we would select? As question. Jacques, what would be your opinion if we now focus only on that one and leave out all the rest?
Well, of course, it's a standard question in LCA, life cycle assessment. So this is why in LCA you have multiple indicators, and you should not aggregate them, except in special cases. So if we only focus on GHG, you can imagine that we will have more resource consumption, more other environmental problems, like, I don't know, toxicity or something else. And I don't believe in a single indicator for driving decisions. Only economists believe that, but not me.
And we don't have our economist speaker
Just a joke, but
present. So no counter argument then. Okay. Okay, so we should avoid this.
But you can, sorry Jens, I think when you do LCA, you, if energy is very, I mean, has a high weight in your importance in your product, and typically like ICT, both manufacturing and operation, electricity is important, then you kind of see that many indicators are following fossil fuel use and the GHG indicator, also other indicators. But of course, the indicator, so we have chosen more or less GHG from the start, but the indicator to go with that has always been the metals. And speak about uncertainty then, but we can actually be quite certain about the metals that are in the product, at least. And that would be I mean, is a good indicator. But to try to say that all these metals have one type of ecotoxicity is harder than. It's easier for, I think, GHG emissions to compare CO2 with methane and so on. But it's much harder, of course, for metal. And toxicity is very local. I mean, the same metal can have very different impacts or the same amounts and so on. So it's very hard. But I think there we are. That's where we are. It's not that easy, and you have to be careful to not draw too. I mean, go too far with your conclusions and without really thinking through what you're doing critically. That's my advice.
If I can add to that, is if you only focus on GHG, it means that you on all the impact transfers, you cannot see them. So you can focus on GHG, but the material footprint, you will not see it. And the water footprints, you will not see it, waste and so on. And the material footprint, I mean, the more you include renewable energy, and the more your GHG footprint will reduce, because you have wind, solar energy, and so on. But it also means that because you included renewable energy, the material footprint of your energy is increasing, and the material footprint of your oil infrastructure is increasing. And when you look at the prevision of the International Energy Agency on material demand for the next years, for the next coming years, is not very beautiful picture. And it means that there will be competition of metals, of different kind of resources between renewable energy sector and ICT, or even on another scale, like the electricity consumption of data centers in US have reduced immensely, especially for hyperscalers, because they use water cooling. So the electricity consumption has reduced, but the water consumption has increased. And you cannot see that if you only focus on one thing.
Okay, I see, thank you. So if we now go a bit in the production, on the production side of ICT with respect to data, we know that where there are many resources that are required. It's of course energy, but of course many other resources and metals or minerals that we need. How transparent are the fabs with respect to these production impacts? Are data sufficiently open, sufficiently transparent that we can use them in a kind of reliable way and while keeping up-to-date data with the state of the technology? It's probably a question for Jens and for Gauthier.
You can go.
Yeah, maybe not. I mean, they don't publish the data. Of course, if you are a large customer, they will usually help you. So I can only speak of own experience that, of course, when we asked for and had Sony and Ericsson and asked for data, we got data usually. I mean, we got data from internal data from Foxconn, TSMC, and so on, and for battery manufacturing, lithium batteries, displays, and so on. Of course, we could not display that and publish it. We had to aggregate it and then publish results for smartphones and so on. And I think that's a problem, but that's the typical problem. And hopefully, I think that most companies, hopefully they will see the benefit if they publish something on their own and say, yeah, we have really done a good research here and we would like to publish it. And I think they benefit from that. And I don't see that we should be, we don't have, companies today are working very actively with reducing emissions. So in general, they don't have nothing to worry about. So but it can be a resource problem, of course. There's too little people working on this. And they may just satisfy their customers and have that's the bandwidth. They cannot do anything more.
So Gauthier, as not being working for Ericsson, is the situation a bit different for gathering data about the foundries and the other equipment manufacturers?
Well, if you are not a big client of any any manufacturers, you got basically no primary data. So you need to rely on LCA database, hoping that they got the data and you are paying the price when you are paying the license. Like, Equin, Gabi is not very up to date. Most LCA databases are not very up to date in today's practice. And you can just at the end rely on other publication in the literature and in CSR reports, and trying to reconstruct your own model. Like if you think about semiconductors, you need to look back at the square centimeter, like for the footprint for square centimeter for GHG, water, energy, and so on. But at the end, you cannot access it, and it means that the primary data will stay hidden or stay under NDA for companies that can get it, like Ericsson, or it just means you will not have access to it. So at the end, or maybe like in the future, I think like big consultancies, maybe Accenture or stuff like that, if they go like partnership with other companies with NDAs, maybe have access to these databases. But it means that you have to be huge to get data. That's the main threshold if you want to look at the environmental footprint of the digital industry.
Hopefully the companies will change their mentality with this respect in the future, let's see.
But it's highly competitive.
Yes.
Like, they don't publish anything because of that.
Mm-hmm. Yeah. All right. Well, that could be also probably a commercial advantage if they can demonstrate a lower footprint than the competition. But if they don't have the idea of what the competition have, then they're a bit afraid, yeah. So let's switch a bit subject. And there is a subject that was favored by many people in the audience because I guess it touches their daily life as a researcher. So we learned about the rebound effect this morning. And then the big question is, how do I include rebound effects in my design? How I design time, can I take this into account? Jacques, would you have any clue for us on that?
This is for me.
Yeah, I'm afraid.
So, so I think first you should frame the problem in terms of limits, as I presented this morning. So think in terms of limits and all the limits that could be modified due to your work or your technology you are working on. And related to that, I think you should also think in terms of what is the worst case scenario. So is it something that at some point is limiting how your technology could expand? is there any? So if you take 5G, for instance, so I'm no expert in 5G, but I looked a bit at this topic. There was a discussion about rebound effect in terms of traffic, so total network traffic. So of course, the network is more energy efficient. It is also more efficient in general in terms of throughput and so on. So you expect that there will be an increase in network traffic due to this technology. The thing is, I don't know if this is really true, but because there is a lot of uncertainty about 5G, but at some point you see, okay, base stations are more energy efficient, but we will put more base stations, and in the worst case, each base station can consume more than, let's say, 4G. So this means that you build something that that could go really, really wrong. So in terms of CO2 emissions, let's say. So if you do the math, you end up with something which can really explode in terms of energy consumption. So I'm no expert in wireless network, so maybe I said something which is not true. So I hope this will be fixed after me. But this, at least, just to illustrate that this kind of way of thinking, I think, is useful.
So imagine the worst case.
Imagine the worst
That
case.
in mind. Yeah, okay. Well, we've seen in the presentation by Jens that network consumption has been roughly stable for the last years. So just to clarify that point, Jens, in your estimates, do you think that with 5G, the global or the total footprint of network or mobile access network would increase?
Yeah, I think the networks has increased because we're building out connectivity in parts of the world where there's a lack of connectivity. But if you take a mature market like European Union, you also saw that it has been very flat stable, even as we have introduced 4G and built out that. And I'm positive for future because we have old networks now. We have the old telephone networks that actually is very energy inefficient, old equipment. And we have 2G and 3G we can take out, and which make rooms so for the same energy consumption we can build out 5G. And those scenarios are what we're looking at together with operators. And I can also say that 5G as a standard are and more energy efficient than all the old standards. So if you build, I mean, there's no choice really. You should go 5G. The thing is that, of course, we want more and better connectivity, and then we will build out more base stations. But will they consume more? We have also a lot of power saving features that are. So in the scenarios we are looking at, yeah, you can build out 5G, but there will be no energy consumption increase for networks. But of course, if we look at a country like, I don't know, in Africa, Bangladesh, also, they are starting from a low level, and in those countries, they will build for sure and consume more electricity. They probably want the same type of connectivity as we do. But in the end, today's mobile networks in the world are consuming 2 watts on average per subscription, human subscription, which I think it's rather low. It's much lower than the fixed networks. So another thing for the future is perhaps we can go full mobile. We have fiber to the radio and not to the house and whatever it is. Because, I mean, to be really energy efficient, we should try to limit all the networks we have in parallel.
Right, so which means
also
decommissioning 2G, 3G to leave room for 5G and not accumulating technologies on top of each other. Yep, sure.
Because since we're speaking about electricity, it means we are focusing on use phase. But in Ericsson, do you have LCAs of 5G radio base station that look at so basically the manufacturing phase and end of life. And do you have like do you see an increase of the material footprint from a for 4G to a 5G radio base station?
No, I mean, sometimes you compare apples and pears here, because if you look at the new typical 5G, so we have massively more capacity, but then it's a high frequencies, and then the antennas are smaller, so the actual product is smaller. So antennas are now integrated. But if you look at the same frequency, I mean, it's more or less the same, but it's much less than the operation. So you typically, the embodied footprint of a base stations is a few tons, but if you run, I have a bad network quality alert here, so I hope I get through here. But in less than, in just a few months, if you run it on world average electricity, which unfortunately still contains a lot of fossil fuels, then you exceed the embodied footprint in just a few months. So we're talking, I mean, radio serving one cell, it's a few hundred watts, and you typically have like 1,000 subscribers in an active cell.
Okay. Mm-hmm.
Or around the base station, so a few hundred in an active cell. And then you have several radios in parallel. So in the end, it's a few watts per subscriber, 2 watts on average.
Okay, coming back to the rebound effect, right? So we have the recommendation to look for the worst case before designing, or at least at the design time. Now the question is that we've seen somehow kind of a mismatch this morning between the talk of Jacques and the talk of Reyna about rebound effects, and remarks and questions from the audience was, how can we reconcile the two aspects? So it seems that on one side we had a presentation that was based, or that was coming from the research area with a multidisciplinary view on the rebound effects, perhaps lacking a bit of case studies with respect to ICT to be able to evaluate the facts. On the other side, we had a presentation that was more on the action and the recommendation and the political level, where we saw that the reflection on the rebound effect was not mature yet. And so how could multidisciplinary research institutions work with kind of institutions like ITU so that together they would include proper recommendation to tackle rebound effects for the IT companies? Is there a path there? Is there a possible collaboration? You're on mute, Reyna.
Sorry, I think that's the most frequent comment now with the virtual meetings. You are on mute.
Right.
Yes, of course, there is a path for the research or academia to join and to collaborate with ITU. And there is an ITU membership for academia. With you know that ITU is a membership organization. So we also look a lot for research institutions to help us, because well, we have the sector members, we have the industry that work with us, Jens from, well, Ericsson work also with us, but there is also the need with the academy. So yeah, there is a path. There are the open platforms. We have other kind of like Kaleidoscope, that is an annual conference where we get papers from academia, and there is prizes for them if in case they can help also for the standardization effort. So yes, there is a path.
So there is a path at the organization level, but at the practical side to actually get results. What would be the task or the actions to start so that we could have rebound effects taken into account into the recommendations? Is it?
I don't think I understand your question. You mean? Yeah, go ahead.
Yeah, I can comment that, and I think rebound is something that we have looked into tried to look into when we looked at the services. So, I mean, networks are pretty complex to study, but then you put all the services on top of this, and how. So what happens in society when we launch all these services and all people start to use them? Yeah, well, now we're into a whole. I mean, we study very complex things, so we try to think more and describe the potentials we see when we have a service like smart meters so I mean, then the services look good, but in the end, the savings may not be that big because yes, we did other things, of course, on a. So perhaps a good example. I mean, we've seen the smartphone, how it impacts other consumer electronic sales and production and so on. But then the whole ICT, one of the things you can really do is you can at any time take a bank loan and go out on the internet and buy anything, and it actually makes it a lot easier to consume, and that's perhaps one of the biggest rebound of ICT.
Right.
That's like the example I always bring up and say, so how do we? Well, it's convenient, but it's also, of course, yeah. We see what consumption do to this planet, and so I'm just, so what to do? I don't know.
If you want, I can add like an experience from the field to that. I was telling it to other people like at lunch. I visited recently in Strasbourg a recycling center, one of the biggest in France. They manage something like 50,000 tons a year for the whole Strasbourg metropolis. And I visited the waste flows. And one of the flow is traditionally like paper, magazine, newspaper, something like that. And it decreased dramatically in the last years. Obviously, we are using less and less paper. There is less printed materials being distributed and so on. But a new flow was created called, I don't know to tell that in English, like mixed paper and cupboard. It's basically all the new flow of waste that came from e-commerce packages, Amazon packages. And it completely compensated the decrease of paper in the first flow with the arrival of the treatment of packages from Amazon and other e-commerce providers. And at the end, the balance is still the same. But it's from the perspective of a recycling center.
Interesting.
Yeah, I think packaging is always like going up. We are buying more things, so it's. But anyway, I would still say that it's quite good that we don't have to print so much paper anymore. That's at least a good thing. But so we have to do something about the packaging of all the products now.
Yeah, and also thinking back that we need to, like, if we think of just GHG, but we need to reduce our footprint by 5, at least in France. Like, we need to reduce our GHG footprint per capita by 5 in the next 30 years. Yep. So yeah, we have to reduce a lot of things.
It's a huge challenge, indeed. So if we have that in mind, so we need to decrease our GHG footprint by a factor of 5 per capita. Sorry?
Just for France, I don't know.
Just for France, yeah. Indeed, other countries like Belgium needs a bit more effort because we have less nuclear in the electricity production. This morning, Stefan Lang told us that the ecological transformation, which is a deep transformation of our society, should come first. And then it will trigger and orient ICT innovation towards beneficial ICT innovation, where it's meaningful for decreasing the human footprint on Earth. How applicable is this pattern for companies in the field of ICT, where there is a huge competition and where time to market is really key? Is there a possibility to tell them, well, let's the ecological transformation start, and then we tell you what we need from the ICT point of view? Or is it impossible?
I hope. I mean, many large ICT companies have really stepped up when it comes to renewables, and I think it's kind of undisputed that we really need to phase out fossil fuels. But we need energy, and then it has to come from solar and wind. I have solar panels. Look on my roof.
Very nice.
Anyway, And I hope that ICT companies also can take the lead in when it comes to trying to, talk, for example, the aluminium industry and say, yeah, we need CO2-free aluminium. But that's a huge problem. Now we're talking roadmaps 10, 20, 30 years ahead maybe. Steel has started also to look into this. Because, we will need a little bit of aluminium in the future. But
the way I understood it this morning, he was not really talking about energy transition, which is getting rid of fossil fuels. He was more talking about ecological transition, which is limiting our footprint on Earth on all indicators at the same time. GHG, of course, with renewable is one of the points, but also reducing the energy footprint and the material footprint on Earth is a more deeper transformation of the world we live in, probably.
I can just short, if I still get the word, comment I usually make, because I have moved out to the countryside and I said, well, we can go back to actually how we used to do things, local growing of food and making small houses out of wood and living in villages, communities. But there's one thing I would like to take with me that we have now, and that's actually computers and smartphones. And I don't know how they look like in the future, maybe smaller and better, hopefully. But there's a lot of other things that we have now and want and so on that we really need to question. I mean, do we really need a big car with a weight 2 tons of metal to drive around? Can we do it in other ways? And there's lots of, do we really need to fly airplanes and so on? At the moment, they don't look that good from a sustainable perspective, but I do think that small electronic devices, if you believe in my numbers and are correct, that they don't consume that much, then yeah, they look quite okay to still have in the future. Sorry, I got long there.
No.
Jacques, what is your opinion?
Yeah, about material footprint. So there are a lot of papers about that, which this is called material footprint analysis, so MFA. And if you look at Sankey diagrams, so all these flows and so on, what you see is that we are mostly building stocks. So in terms of weight of all the flows which are consumed, and if you look at abiotic resources, it's mainly to build stocks, so to build infrastructures and so on. And today I think it's mainly in China. So in our countries in Europe, we already developed most of our infrastructure, so we are not consuming that much resources for that. But yeah, when you look at all these diagrams, you see that even if we reduce consumption, like consumption you have every year from products and so on, it's not enough, because most of the flows, they are accumulating to build to build roads and buildings and things like that. So it's not as simple as it looks.
Right. Okay, so a question that was quite important for the audience in the afternoon was linked again to this infamous rebound effect. And if we acknowledge the fact that innovation actually triggers some kind of rebound effects, and so that the footprint of ICT is roughly stable or is slightly increasing, but it's not decreasing because we improve efficiency. Both from the electric energy point of view, but also from the resource point of view. Does it mean that to stop the vicious cycle of rebound effect, we should stop innovating, or we should stop improve energy efficiency? If we do that, all things being equal, would it stop the rebound effect and the absolute footprint increase of technologies in general? Yeah, Gauthier.
I will try to explain that with an example. So first thing, like a rebound effect is complicated because it takes place in a socio-cultural framework, in a specific economic framework, and some like the rebound effect somewhere might not be exist in another context, and that's why it's always very hard to take global rebound effects. But like having trying to reduce rebound effects is not something that will reduce innovation. To give an example, it is not really a rebound effect, but at least will give you an hint. Is like in like the smartphone industry, like the manufacturers, the production has been decreasing since 2017. It increased a little bit at the beginning of 2020, and it increased again when 5G arrived. I mean, 5G for smartphone manufacturers was obviously also something to start selling more smartphones again, because they were basically falling year after year since 2017. But we are still shipping like something like in 2019 we were shipping 1.33 billions of smartphones a year. 1.33 billion of smartphones a year. And because there is marketing, advertisements, incentives and stuff like that, we are thinking of a smartphone in a way that will last 3 years, 2 years if depending on your use, 4 years depending for someone else, etc., and so on. But to actually design a smartphone that will last 10 years, you really need a lot of thinking. You really need a lot of innovation, but not only on a technical level, on a legislative level, on an economic level. And what we need is, what we might need still want smartphone in the future, but you might not want a smartphone that is designed for many reasons to last for 3 years. You might want something that will last 10 years. And to achieve that, and to also reduce, obviously, the sales of smartphones, you will need a lot of thinking, a lot of innovation. So limiting rebound effects doesn't mean having less innovation.
I like this answer. I think it gives a little bit of hope and thing to engage in for sustainability in the ICT sector. Is there a way, Reyna, that we could motivate companies to design smartphones that would last 10 years?
I think it's a sorry. Go ahead, Reyna.
No, I was thinking because this is a tricky question. You know, it's like we, for example, in ITU there was the development of the universal charger, for example, and this charger, well, it's being right now revised, and it was also within the talks with the European Commission in order to see how this could be also revised and make it a little bit more part of the Green Deal, etc. For me, it's very difficult to talk from an industry perspective, to be honest, how to make them to do a smartphone that can last more than 10 years. I know that there is a shift to circular economy, to a shift to better designing, etc. I'm sorry that maybe my answer is a little bit vague, but no, I don't know the real solution, how it can be. I know that through collaboration, through this kind of forums, or also through the standardization process as well, that you have different stakeholders, you find a way maybe to work on that. Jens, I don't know, you wanted to also to comment on that.
Yeah, I mean, when we used to design smartphones, or when I used to talk to Sony, it was of course, yes, we want them to last, because that would be sales argument for us, but it's also about price and how will the smartphone be too heavy, And either is like if you drop it on concrete from 1 meter, the impact is still, I mean, it's very tough to design a product to endure that. And I mean, still it's smartphone. We use it for like, I mean, many hours every day, and we take it up and down from pockets and every day, many times. So I think what the developer should, I mean, they should enable easy repair screen, battery. Sometimes you kind of, and when looking at it, it may not be that easy and quite expensive. So I don't know, maybe Apple should step in here and talk about this, because they think about it a lot, I imagine. I think the new phones is one sales argument is that they will endure and last longer.
So repair is one side of the coin, but of course there is the obsolescence aspect as well, with the new standards coming and heavy software updates and this kind of things that may limit the lifetime. So if we have the repair policy that are encouraged, are there also policies that are discussed about software obsolescence or evolution of technology over time?
I think for us in networks, there's no problem because our customers are very professional business and they want backwards compatibility. And now we're talking decades. So,
yeah.
But I imagine that the device manufacturers, they want, of course, of course they know that if they make a much better new product, people will buy a new one that actually don't need, because the one they have actually works. And that it has always been like that in this industry. But I also knew people that go and buy new cars every third year because they can afford it. And now we're talking about cars. Yeah.
Well, like on smartphones, I had a discussion with the technical lead from Fairphone. Like they managed to do an update for Android 9 that was released like 5 years ago. So it's very rare to have an update on an OS that have been released 5 years ago. And what was really a bottleneck for them is access to like on Fairphone there is a Snapdragon IC, and the fact is the company doing Snapdragons, I don't remember the name.
Qualcomm.
Qualcomm, sorry, is not doing maintenance anymore on the chip. So they could not do an update on Android 9 because they could not update the chip. So they had to do reverse engineering on the chip to do their own software update for the chip, then enable to do their own updates on Android 9. And Snapdragon, it was a 900, I think, something like that, was released like 3 years ago. Or I mean, at least they stopped. They just maintained it like for 3 years. So it's also like on a very on a deeper level. The way we're designing and the IP and of chips is also a huge impact on consumer products. For professional devices is another story.
Okay, so every piece of the puzzle has an impact. Not only the software updates are to blame, but also the hardware maintenance of the components. Question about new technologies, right? So we are discussing smartphones. Smartphones are already there. But we've seen in the presentation by Jens that the new devices are more in the IoT kind of field, where the number of devices is increasing. Today we might have quantum computing over the place and other new technologies that we don't use in our pockets or in our data centers so far. So for these technologies to be deployed, would it be meaningful or even possible to impose an energy budget for a given technology to a certain company? It means that in the context of the Anthropocene, should we at some point give a certificate for a company to exploit the technology for that amount of terawatt hour or gigawatt hour per year and not more? And what to do if they don't respect this budget? It was more a question for Stefan Lang, actually. So I'm looking for any opinion on that aspect here.
I have one.
Yep.
Yeah, I think it's a very good way to frame the problem, and because of all I said about rebound effects. So if you take machine-to-machine communications, there is no limit. So you cannot use your phone more than 24 hours a day.
Right.
But when we are speaking about machines, there is no limit. You may have billions of machines talking to each other and so on. So yeah, well, there is no limit in terms of energy consumption from all these machines we will build. And one way to ensure that is, of course, to have a regulation and to put a limit by regulations.
And how do we decide how much to which technology?
This is the difficult question. So first thing, we have to accept that we need to set limits. And even this, there is no consensus about that. I mean, there are people saying that we should not put limits and so on. I don't know. I won't tell the names, but no. But these are real questions, and then how to. So we are speaking about quotas and how to distribute these quotas. I don't know. We should decide. I mean, we should decide as a society. It's not a technological question, because my opinion with the previous question was we were thinking a lot in terms of as engineers about problems. So seeing at the problem in terms of technical ways to repair, technical ways to do that. But if we repair smartphones, what about the market and the economy, which is based on selling smartphones? This is not that simple. So this is not a technical question. This is a global question, an economic question for me.
Gauthier, you agree with that opinion?
I think I have not as much idea on that. Yeah, it's complicated because, I mean, for me the ICT sector is something very weird because it's at the same, it's very concentrated in a way it's constructed itself, like it's very concentrated points of manufacturing in the world. It's very, and at the same time it's diluted in every sector, and that's very hard to actually grasp the nature of ICT because of that, being concentrated and diluted at the same time. And like I was thinking about cars, you know, because of what Jen said before about the weight of cars, and they tried, like in France, they try to regulate the pollution emission factor of cars depending of the weight, and instead of their
You mean normalized to the weight?
yeah, because like, you know, like right now, like the pollution of cars is a relative value of CO2 per kilometers, and they wanted to do a new regulation based on the maximum amount of emission depending of the weight of the car. But and something I understand quite soon, for a while now, is industry doesn't like absolute value; they like relative values. But absolute value is harder to deal with because it puts a limit. And so in France, the car manufacturers lobbied a lot. So the legislation will only take place for cars that are above 1.6 tons, which is like less than 2% of the car fleet in France, and that is also a bit and yes, SUV weight a bit less than that, so they will not be affected by that. So you can also play with a restriction for a while if you don't have the political framework or the political doctrine that allows for this legislation to come alive. That's all I can say. Sorry, it's not very helpful.
Oh, I see. Very interesting. Any further questions from the audience for our speakers of today? There is a question at the back, Nicolas.
Thank you. Yes, I have a question for Reyna actually, and for the other speakers too. In your talk, you mentioned that you have many standards. One is to decrease CO2 emissions, and the second one is to decrease the cost of the technologies. Isn't it like conflicting standards that actually will never be met together? Like, shouldn't we increase the cost of technologies to induce a real decrease of the CO2 consumption?
You mean the standards on the trajectories, or which standards?
Yes, maybe
Because
the
what I mentioned,
trajectories.
what I mentioned was the standard on the trajectories to meet the Paris Agreement,
Yes.
but not the one. In order so the ICT sector could commit the one on the greenhouse gas emission trajectories for the ICT sector compatible with the Paris Agreement. And can you repeat your question again, if you don't mind? Sorry.
I guess I will reformulate to see if I catch it correctly. So on one side, there is the recommendation that is made to put the greenhouse gases emission on the Paris Agreement trajectory, so reducing the footprints. And at the same time, there is recommendation for limiting the costs of the ICT usage, being either equipment purchase or subscriptions, or I don't know. But as we learned in the seminar about the rebound effects, as soon as you decrease the cost, you tend to motivate more usage of the devices. And so the question is, could it be the other way around, like increasing the costs of the technology so that the usage does not explode, and the global absolute footprint is going down with energy efficiency improvement?
I remember now. I remember because one of the what I mentioned was the smart energy solutions that decrease the cost of maintenance as well. I guess that's what you are meaning, right?
Yeah, was it this?
Yes, probably, yeah.
No, I was trying to look. Oh, I'm sorry, David. It's hard for me to answer the relationship right now. That question. Apologies.
Okay, no
Yep.
problem.
I can say something.
I think the cost of energy for operators on average in the world is just 1.5% or something. But for some operators, of course, it's a higher cost when you need to have these generators on. But the ICT sector has more or less all over the sector low cost in relation to value. So I think the word on average is like 10% is energy cost more or less, and for the airline industry, it's like 1/3 is the jet fuel. But for our industry, it's about 1.5% for the networks. Data center, I don't know, probably more there maybe, but when user device operation, it's nothing. It's no customer even care about it because it's not that much. Maybe only for if you're a high hardcore gamer, then you pay a few hundred or a few tens of euros a year. But for everyone else, it's a very small cost. But so I don't think the cost is and still, I mean, the operators and so on, they want to switch to renewable costs just to get rid of the CO2 emissions. So I don't think it's such a big cost issue. It's more
at least from the energy usage point of view, as you mentioned. Yeah. Okay, Gauthier?
To reflect on that, I know that in EU there was discussion, maybe before COVID-19 happened, or maybe in between, I don't know, to put a carbon tax for electronic devices imported into EU based on the amount of carbon they were embedded. Which implies that you need to know how much carbon is embedded in your devices you're importing. But there was this idea of actually trying to control or to regulate at least the manufacturing section of your life cycle, because like in Europe, we don't have that much manufacturing capabilities anyway. So most of it will be in Asia and other part of the world. So we are mostly importing everything. Like for instance, in France, if you look at electronic devices, it's our third biggest part of carbon emission. Of carbon importation. Like 90% of all electronics in France are imported. It's imported carbon. So they were thinking of doing that in EU. I don't know how it's gonna happen. If we do it, I think Americans and Chinese will not be happy about that. But it's a way to also have a pressure to force manufacturers to adopt better environmental standards, and at the same time to kind of force them a little bit more to open data. So it will go against the European Commission policy of free trade, but in the ICT sector, nobody is doing free trade. It's only protecting markets. I mean, the USA is not very well. It's not what we call the free market when it comes to software services and other stuff. And same goes with China or even South Korea. So we can, if we think that we can regulate emissions for the ICT, like the price of emission for the ICT sector, then maybe we can do it at the European level, but we cannot do it at a lower level in Europe.
Okay, thank you. Yeah, there are other questions in the audience.
Hi. I just introduced myself just a bit. I'm a freshly graduated electronic engineer, and we talked about, I aim to make long-lasting devices, and we talked about the lifespan of the device, and we mentioned repairability. And I was wondering if maybe ITU was proposing some standards to propose ways to make devices repairable or longer lasting.
There are, yes, I am on. Yes, there is a part of on the part of the circular design, on the circular economy, which is proposed to develop long-lasting devices. And I guess this will be also good contribution for the November meeting to the expert to tell them that about all the results of this debate and also how to develop a standards more specific on that, because there is a part on the circular economy side, but not specific right now.
As of this stage, is it mostly for equipment like smartphone and computers?
Or the ICT devices.
Mm-hmm. Okay. And so what about the electronic components that are integrated into everyday objects and in cars and so on? Are there initiatives at the ITU to also foster repairability at that level?
Not right now.
Is it maybe outside of the scope of ITU?
Yeah, I think so. I think most car electronics is like car electronics.
Right.
It's not. Of course, they will use processors and components that communicate internally in the car, but the communication outside is just a very small part of it. So, but car electronics has really grown in the last 10 years. So they are now second largest electronic consumer after ICT. So they consume more than the entertainment and media sectors, more than TVs and the traditional consumer electronics. You have more electronics in cars now. Every year we put more electronics in new cars.
And now in bikes too, it's coming.
Yeah.
All right, do we have a final question from the audience before concluding this debate? It seems it's all clear for everyone. Oh, sorry, there is a question. A last-minute question on the buzzer.
Hello everyone, thank you very much for this interesting debate. I have a last question. We talk a lot about the IC circuits, but we never mention the critical materials. Are the critical materials or raw materials considered for ITU or regulations? That's all.
So let's start with radar, the critical materials with limit availability or geopolitical issues, kind of in the scope of the ITU recommendations.
We talk about yes, there are some work on the critical materials, on the rare material, the rare mining. If there is a kind of work on that, yes.
Okay.
I can maybe say that we published a paper about the material footprint of ICT and entertainment media in 2018, I think, looking up to year 2015 and individual also for a lot of materials. So you have, for example, a metal like indium where ICT use like 90% of the indium. We are running out of indium, but it will only be a problem, I guess, for the ICT industry itself. I don't think there's any other critical use. Then the touchscreens really depend on indium for those, but we probably invent something if we. So it's a discussion about the resource. How should we do it? It's very hard to recycle. I think they look into that, but I imagine it's hard. I guess you need to like take this thin layer in some kind of machine off, and then you get some indium-rich sand or something. I don't know.
Gauthier, what's your opinion on the criticality of material availability for the ICT industry?
I mean, like it's like when you think of a smartphone, it's like 45, 50 different metals, I think, involved in manufacturing. And like it's very complicated topic because there is codependent metals. There is, I mean, you can get palladium only if you open like a mine of aluminium, I think, because you cannot open like a mine of rare or rare metals just by itself. You need like to exploit it in a bigger mine. So often demand in this sector is very complicated. Even the calculation of resources and reserves, which are two different things, is complicated. And every country like China, USA, Europe have launched like missions, specific commissions to secure supply chains of specific metals and what we call like rare earth minerals, because it's not evenly distributed on Earth. It will be hard to extract, and it will create pollution depending on how you are doing it and why you are doing it, and it will also be very vastly used for energy transition, like for wind turbines and other kind of equipment that you need for solar panels, for all kind of clean energy. And looking at the growth that we need in renewables to make it work, you can have a lot of competition on these minerals, and it's going to be very hard in the coming years to see who's having the monopoles on which materials or not.
David, if I may, just because of I was checking the standards, and there are two standards on procedure for recycling rare metals in ICT goods, and there is another standard on measurement methods to characterize rare metals ICT goods as well. So
okay, so that's a good resource to check then,
yeah,
to dig deeper in this.
I can put it in the chat if you want to share it after.
Yeah, thank you very much. All right, so a question, Noemi?
Okay, my question is a bit complex and it's for Jens Malmodin. So you mentioned that for you, network did not suffer from obsolescence, but in my opinion, we witnessed a succession of different generation of network protocols. And the reason for this is often mentioned to like new generation of networks come to fix like congestion problem and so on. So we can see this as a form of obsolescence. For example, 5G is often mentioned as being needed to enable all these new IoT devices that we will need to put in circulation in the upcoming future. So, which will lead to all kinds of rebound effects. So my question is, as an infrastructure or service company such as Ericsson, which provide networks, do you feel that you have a responsibility in terms of enabling or disabling this rebound effect, for example, linked to IoT? Or would you say that this responsibility is not yours and should be put more on like regulating bodies or other entities? I know it's a bit complex, but I hope you got my point.
Yeah, I mean, we of course develop better network products that will make better networks, and of course there are salespersons that sell them and talk about them. I would say that, I mean, it's a very natural development, and the new network products. Typically, if you look at all my data that I collect year by year, you see that the average energy consumption goes down per subscription, per line, or how you measure it, despite we have way more traffic on the networks. I mean, 5G is just a natural development, so it's the standard is better. It allows much more power saving features. You can run the networks with less energy. But the thing is, of course, that now we also allow higher frequency, and then of course you need to deploy more base stations. But I mean, we don't have to do that. We can just take out 2G and 3G and deploy 5G on those frequencies that are freed, and then we can run networks with much higher capacity for less energy. It's up to us. It's like, yeah, we have the tools we can do. And I think the Internet of Things is a very interesting subject. You can do a lot of good stuff with that, but you can also, of course, make mistakes. And to me, of course, we shouldn't like just throw out all these electronic stuff and forget about them. No, we should really deploy them smart and make sure they can do a lot of good stuff in buildings, in manufacturing. But typically you add them to already existing electronic equipment, and you don't, I mean, I have been looking into the smart home and smart meters and so on for a long time. And I said from the beginning that a lot of these devices are actually not that smart. It's just for playing around with, switching on and off the lights and so on. And those little things will be there and consuming electricity. So we will not save anything here. We will add things. But today I think that they have become a lot better. So yeah, sure, if that's what we want, that's what we can do. But if you're looking into when we run new modern buildings, I think we have examples in Sweden where the new buildings are very efficient, thanks to they can manage all flows of air, water, etc., energy inside them in a very efficient way. And then the little extra we added for the smart sensors and whatever really pays off in the end.
Okay. So to conclude, if we have these smart devices that allows us to reduce the footprint of buildings and transportation, for example, how, Jacques, do we prevent this to be ruined by the connected shaver, the connected swimwear, and all these futile or crappy applications that the human really don't need at this stage? How do we put boundaries on that?
I don't know. First thing is we should first look at the plan. What's the plan? What industrial are promoting, and what is the plan? Because yes, we can do good things, but what's the plan currently? So for 5Gs, I think I saw that a lot of bandwidth will be used by, how do you call this, like a camera for in the streets and so on. Yeah. So streaming 4K everywhere, and so I'm not sure. I'm not sure it is enough to say that we could do good things with the technologies we are developing and putting in place. We should first look at what the plan and what is the purpose of this technology, and to have an idea of what will happen.
And what could be the worst case, so that we can take it into account.
To add to that is, and to go also in the sense of chance is, you can put as much smart meters that you want in a badly insulated home. It will not do much. But if you have like a plan on a countrywide plan for insulating houses, making better heat transfer in buildings, then you can add a layer of connectivity that actually can be very beneficial. At the same time, you can invest in your public transport and make it make it good, making like reliable and enable to reach a lot of people. And adding application on that navigation app can really help for this public transport to get on. But you can have a navigation app on a very crappy public network. The result will be not as good as we expect.
So let's start the ecological transformation and then add a smart layer where it's actually needed. Okay, thank you very much for this debate, Gauthier, Jacques, Reyna, and Jens. It was very interesting and a pleasure for me to discuss with you. I hope that you learned things this afternoon, and this concludes the debate.
Thank you.